Hi, so we're going to continue with Dr. José Molina Mora. He's joining us from the University of Costa Rica, where he's a lecturer and a researcher. And he has a microbiology degree from the University of Costa Rica and of bioinformatics from the, a master's in bioinformatics from the University of Costa Rica as well. And he did his PhD studies in bioinformatics at the University of Costa Rica and the University of Fudan in Shanghai, China. Welcome, thank you.
Hello. Hello, thank you for the presentation. Yes, today we're going to talk about the genomic surveillance of SARS-CoV-2 in Latin America. This is part of the Cabana project. And basically, the point here about the pandemic in Latin America, we're talking that this region has been impacted with more than 56 million of people with the diagnosis of the COVID disease, with more than 1.5 million of deaths. And this is in part explained by the huge ecological diversity and the different social problems that we have in our region. Basically because we have a situation in which we have own features, different efforts have been made to try to improve the local surveillance. This, under this assumption, was that Cabana started a project for the genomic surveillance in Latin America. I became here as a secondee of Cabana project. Basically, with this project, the SARS-CoV-2 genome, its evolution and epidemiology in Latin America, basically during 2021. And we were analyzing different sequence data from 6 countries. In the case of Peru, they included another one, Bolivia, as an extra country, but we have Mexico, Costa Rica, Colombia, Brazil, and Argentina. And one of the secondaries with Jonathan and Erwin, that we have been working basically with the data from Mexico, Costa Rica, and Colombia, and other teams are working with the other sequences. Basically, we have 2 main steps in this project. The first one was to provide sequences for the genome databases of SARS-CoV-2. The first point here, of course, in each country, different efforts or the local surveillance programs were including samples that were supported by Cabana, with different samples of in these 6 countries, and using different technologies that they were already using, Illumina, for example, or Nanopore for the sequencing, and then different steps for the genome assembly and the further analysis that we expected with that sequences. And a second step, because we have different comparisons here, we decided to start analysis using databases with different, not only the sequences that were obtained by the project, but also using other sequences in the database, trying to identify some specific patterns for the genomes that were circulating in Latin America. With that, we finished a comparison using information about, for example, the variants that were circulating in different periods of the year, mainly 2021, mutation rate, or the comparison of the cases that have been sequencing and the diagnosed cases, try to identify the portion of people that in which we have information at the sequence level. Basically all together to have a contribution for the genomic surveillance of the pandemics in Latin America. With that, In the case of Mexico, Costa Rica, Peru, and Bolivia and Colombia, we have more than 1,100 sequences that were, right now they are in the GSA database. And basically we use different best practices to identify or to finish the genome assemblies using contiguity, correctness, and completeness, different criteria to make sure that we are obtaining the best sequences as possible with the different practices from a bioinformatics point of view. And here we have the data for the three countries that we were working mainly. In the case of Costa Rica, Colombia, and Mexico, with the data access, for example, GSA's database, and the different pipelines that we were using at the lab, and also at for the bioinformatic analysis. Depending on the needs that each country had regarding the sequencing process, for example, it was kind of complicated to get samples at the same time with the same technology. So basically, the Kavana project supported the local programs. That's why we have some differences, for example, in the periods in which the samples were sequenced or the technology. For example, here in Mexico, samples were obtained mainly in September. Meanwhile, in Costa Rica, we have samples for different periods of the year. A similar situation for Colombia, mainly in September and October, and the other countries that were participating as part of the project in a similar situation using different periods. Because it was kind of difficult to make a comparison in that conditions, we decided to finish the second step that we already talked about, the analysis using databases and trying to identify some patterns and eventually to prepare a final publication that we're in that part, including, of course, the samples that we sequence as part of the project, and different databases, not only the sequence, but also the metadata or other information regarding the patient, for example, trying to not only to contribute with the genomic surveillance by providing the sequences as we did it in the case of Kavana, but trying to identify some patterns regarding the circulating genotypes in 2021. Here we have a comparison of the different efforts that has been done in different Latin American countries, in which we have the number of cases, the COVID-19 cases, and the sequence samples, trying to explain or to identify the percentage of samples that have been that are being sequenced by the different local programs, in which we have the data for the different countries, in which Mexico is almost 1% of the cases, basically the first one. But if we compare these values in Latin America, in the case, our region is basically not the same that we have been reporting worldwide. So this is a interesting point that it can be. We are talking about sequencing. Of course, you can have other strategies to identify the genotype, not only sequencing, but in that case, using databases is the information that we have. Yes. Then for the sequencing, for the circulating genotypes in Latin America, we have a diversity, as we can see here, with different variants of concern that mainly, as we know about the variants that in the second semester were Delta, which was predominant in Latin America and the rest of the world. And eventually with the introduction of Omicron, we have a movement of that or displacement of the genotype Delta to Omicron. Here we have a comparison during 2021 in which we have the countries that were participating as part of the project. For example, here in the first semester of each country, we can identify some specific patterns with some variants that we have in different colors. For example, in Argentina and Costa Rica, the patterns are very different than the pattern that we found in Colombia or Peru. But when the borders finally opened completely, basically all were, in this color, we have Delta, as you can see in the second semester for basically all the countries, we have Delta as predominant in the circulating genotypes, according to our information. And this pattern is similar when we are talking about the region as a unit, and then when we compare worldwide. Another analysis that we finished was the comparison of specific lineages that were circulating in Latin America. We were able to identify more than 83 83 lineages in which Latin America was predominant, reporting that lineages. And for those lineages, 51 were reporting a frequency more than 80%, as you can see here. And here we have some examples of the last case. For example, here we can see that a specific lineage, Panama was predominant. And the first report of that sequence was, in this case, Panama. But we have other patterns, in which we have, for example, that a predominant lineage was a Latin American country, as in this case, Brazil. But the first report was, in this case, United States. It means that, of course, we have a mobilization of people. So we are comparing some patterns in this case. Some of the lineages has been reported before. For example, in a previous talk, Seleni was talking about the specific lineage for Mexico. We have the same pattern in Costa Rica with this one that we previously identified in another study, in which we identify a specific mutation in the spike protein. And we already published this as part of 2 different works, and in which that lineage was predominant in Costa Rica, while not in other countries, as we found. And also this gave us the opportunity to analyze the structure of the spike protein, talking specifically about this mutation. When we compare the mutation frequency of the spike, we have a pattern that is in Latin America that is similar worldwide, as we can see here. Basically, in this color, this green, we have the introduction in those colors. We have the introduction of different variants of concern, mainly here in this one with Delta, and finally with the introduction of Omicron, in which almost 30 mutations were identified for the spike protein. When we compare that using the mutation rate, we can see a pattern that is the same for the rest of the world, in which, depending on the time, we have an increment of the mutation rate in Latin America, as we can see here, and the different colors are representing the variants of concern, in which we can identify how Omicron, for example, has been, as we know, the variant with the most accumulated mutations. And finally, with all this information, we have been preparing a publication proposal, as we can see here, basically trying to give an overview of the pandemic. Of course, talking about the genotypes that are circulating in Latin America. So this effort, part of the Cabana project, is trying to contribute for the genomic surveillance, as I said, by providing genome sequences to databases, and then using this and information provided by the other efforts to identify some regional patterns. And possibly a coming step will be the analysis of specific lineages that were enriched in each country. Probably that can be done by the local surveillance services. Part of the limitations, we were talking about the timing, that is kind of complicated, but at the same time, it was a contribution to the local surveillance programs, basically depending on the needs that they have. Also, as part of this project, we think that we have demonstrated the local efforts and capability that Latin America has, not only talking about the laboratory, but also the analysis at the bioinformatic level. And of course, the force to improve the collaboration network. Finally, I want to thank to Cabana, and in my particular case, the University of Costa Rica, in which I'm working, but a special thanks to Alfredo Herrera that makes possible this, my participation as secondary, and to come here to Mexico. Professor Rebecca Campos in Costa Rica, that is the leader for the Cabana, or working with the leader of Cabana project in Costa Rica. Professor Marco Cristancho, that was working with us, with the secondaries, mainly at the first part of the secondary with different workshops. And my colleagues, Jonathan and Erwin, that they are in Colombia, and we were working with the analysis here. And finally, to Cinevestab team to make possible to come to Mexico. And thank you very much.
Thank you so much for a very interesting talk. And also, I really want to highlight the fact that Jose is a secondee. So this is one of the core aims of Cabana, training people. And actually, Rebecca Campos, who's the lead of Cabana in Costa Rica, she was also a secondee from Cabana, and now she's a lead in the Cabana project. So it really has fostered the formation of really high quality human resources across the region that now can be used in emerging things such as this pandemic. So if anybody has questions, I'm going to start with a comment from Kat Brooksbank, who she wrote it on. So Cabana has been a vocal advocate of open science from the very beginning. What proportion of the raw sequences made it into the public domain? And what are your plans to get them all in?
Okay, it's a complicated question. And in a moment from the project, we were talking about to share the raw sequences, trying to prepare a database. But at this moment, we have shared the assembled sequences. But in general, this is a decision that maybe can be discussed with the team. But there are options, of course, as part of the Cabana project to share. And we are in all cases, we can think in the reuse of that raw data to make other analysis, and not only talking about the assemble, but for example, in Costa Rica, we have another type of analysis that we already finished, trying to identify co-infections using the same raw data. So we have implemented a metagenomic pipeline to identify co-infections using not assemble the genome, but using the same data to identify possible co-infections that have been, they were reported in some cases worldwide. So we are ready with that. So it's important not only thinking about the genome assembly, because that raw data can be used for other analysis.
Marco?
Thank you. No, just before a question, or I'd like to congratulate Jose. He's worked really hard during his secondment, and his success of the story of Cabana, because rapidly during his secondment, from being a trainee, he became a trainer of other secondaries. So that's a great example of somebody moving rapidly to what we want to produce in Cabana. Just I wanted to ask you if you think that our data from Latin America can be an example of how lineages were detected because of the amount of sequencing that was done. I mean, for example, if we see the case of Brazil, of course they have a large population, but also they do a lot of sequencing. So probably that's one reason. So maybe we can argue that in a publication that it pretty much depends also on the amount of sequencing that we do to try to detect lineages in certain populations and those kind of things. Thanks, Jose.
Yes, it's a very interesting point, because in the case of the force of Cabana, yes, we have been contributing with the sequences, but we know that it's only a small part that the sequences that they can be obtained, and to identify specific patterns maybe need to be improved by using sequences from different sources. But in general, it's possible to identify, as you said, and we already found some specific lineages, and probably further analysis will be done to identify the specific, the relevance of that specific lineages.
I just wanted to comment also on the raw sequence data that our idea is to submit to INA, to upload to INA, the raw sequences. So as soon as we get organized with that,
Great.
we'll
Should talk over lunch if possible. Okay, thank you so much, Jose.
Thank you.